All right. Welcome to the Statistics 220 Fundamentals of Data Science project for what team are we? I don't think we have a team number. I'm Matt Foster. Joining me today, we have Alex Fellows, Jenkins Sun, and Jordan Plasmeyer. We have decided to look at data about border crossings into the United States. This was collected by, I believe, an official government office, so it's accurate. We wanted to answer three questions, kind of: which border is most likely to be crossed, what state is most likely to be crossed into, and then what is the most likely method somebody will use to cross the border. Included below, we have links to the raw data set, links to the cleaned data set that we did, and links to our markdown file that we used to clean up the data set, as well as several other links leading to our graphs, our data exploration summary, and our research abstract proposal. So moving on to how we cleaned up the data.
So cleaning up the data and make it predictable was relatively easy. It mostly involved changing some names. Port names became checkpoint, and port the code became checkpoint code. Matter became method, and the value became people crossing. These name changes are all done in the name of the simply and being able to understand what we comments grains without thinking. Furthermore, the state column previous contained only the state abstractions. We assumed that many people could be unfamiliar with aberrations that did not belong on states, so we changed the aberrations to full state name using the case when we command. The R markdown file used the clean data being included in the file and the remains of scrapped ideas, including splitting up the data and evolve the graphs, comparing the proportions and the methods over time. In the end, we went with graphs comparing the proportions and the methods states instead.
So moving on to our graphs. So this is essentially the complete R markdown file we use to make our graphs. It's just been knitted to HTML and embedded into the website. We start just by importing all the libraries we need, and then we start with this bar graph that shows a comparison of each method used to cross by all the states. So as you can see here, each method, barring Ohio, has a similar proportion that was used in every state from the start of when the data was being collected to the final collection period. So each state had about the same number of people entering by bus passengers, the same number of people entering by buses, and so on and so forth. So this code chunk here, what it does is it takes, first off, it takes our borders and assigns it either, if it's the Canadian border, assigns it a value of 1, and if it's the Mexican border, it assigns it the value of 2. And then moving on to, we did the same thing with the states. We gave it their number. If you were to put them in alphabetical order, there are gaps in the numbers because not every state is a border state. So only the border states were included. And then with the methods, again, we did the same thing. We just went in alphabetical order based off of the listings here on our bar graph. We did this so that the linear model, like the LM model, would work, the command, and so that the cart models would also work, because when we tried to do them with the normal factor variables, it didn't work. So we had to convert those into numeric data so that we could use them kind of correctly. So the first model here, we were trying to predict which border is most likely to be crossed. And it's fairly small. And we came away with, if there were more than 22,000 people, it was likely to, the CART model decided that it was likely to be the Mexican border. If it was between 22,000, or sorry, just less than 22,000, sorry. If it was between 22,000 and 162,000 people crossing the border, it was most likely to, it could have been either. But if it was greater than 162,000 people, it was most likely to be the Canadian border. And more than 162,000 people, that's the majority of people. So the Canadian border, we decided, was the one that was most likely to be crossed. The CART model for states, it was not all that helpful converting it into the numeric data, because it gave us state number 29, which is not actually part of our data set. So we decided that it was sort of a split between Montana and New Mexico. This was like, we all kind of agreed this was the only thing that jumped out at us as weird, because I don't think anybody saw Montana or New Mexico being the state that was most likely to be crossed. So that was the only thing that didn't really make 100% of sense. And moving on to the methods. Here, there was only one split. And it looks like the most common method, this one in dark blue, that was personal vehicles. That makes plenty of sense. Most people entering the United States are going to be doing so using their own personal vehicles. So the Canadian border is most likely to be crossed. The method is most likely to be a personal vehicle. And then the state is a toss-up between Montana and New Mexico, although this conclusion is likely not based on clean methods, I suppose. So at best, that state is a shaky conclusion. Further research will probably need to be conducted. Moving on to the research abstract proposal.
So the research abstract proposal, so for the data set that we're using, measures instances of border crossings into the United States from Canada and Mexico. Variables are going to include the state which the border was crossed, the checkpoint of crossing, the checkpoint's unique ID code, the state that the data was collected, the method of crossing, and the total number of people that crossed using said method for the time period. Most of the variables are categorical, with the only numeric variables being the number of people and port codes. So column 1 is also numeric, but that was not a part of the original data set, and it only tells us the number of the data point we're assessing is out of 355,000 so data points. We plan to use all of our data at one point or another, but not all at once for every question we are posing. So speaking of, we plan to ask and answer these 3 questions. If one crosses the border, which border are they most likely to cross? Into what state are someone most likely to cross? And what method is someone most likely to cross into the United States with? Easily the most important variable in our data set is going to be the people crossing. We call this one the most important variable because it will use it to answer every single one of our questions. Other important variables are going to include state, border, and method. As each question we ask deals with at least one of these 3 variables. So according to the original publisher of the data, Divyansh Agrawal, the information contained in the data set was provided by the United States Bureau of Transportation Statistics. It counts incidents of people crossing the border into the United States. Data points were collected over the course of 24 years from January of 1996 to February 2020. Agrawal posits that the data can be used to predict the daily, weekly, or yearly crossings, as well as the total average number of crossings in future years. So this extrapolatory information is most useful to border authorities that want to prepare themselves ahead of time for a possible number of entrants into the U.S. that they will have to process according to Agrawal. So with that, we will move on to site pages.
So the data concerning U.S. border crossings is a fairly straightforward set of data. It contains information gathered over 24 years from January 1996 to February 2020, which concerns entry into the United States through the Mexican and Canadian borders. The data only has 7 variables, which are the name of the border checkpoint, or it can be called ports, the port's unique code, the dates the data was collected, which was on the 1st of the month at 0000 hours. The methods used, which included personal vehicle driver, personal vehicle passenger, trucks, truck containers empty and truck containers are full, buses, and bus passengers. And finally, the total count of people crossing the borders using the described methods since the last data collection date. When looking at this and trying to make sense of all the data, we believe that it would be a good idea to explore methods by state to see if the prevalent method of crossing varies by state, or if it was on a larger scale, if the prevalent method varies by border. If there is a dominant method or the majority of the border, we were looking at that and just trying to look at different ways, see how state and the methods would vary.
All right. Well, that's it. Thank you for watching our presentation.